Hello students, in this video we are going to discuss about open circuit test. As we all know, the transformer losses are of two types, iron losses and copper losses. And whereas iron losses are further divided into two categories, hysteresis loss and eddy current. On transformers, we conduct open circuit test to measure its iron losses. Before discussing open circuit test, first of all, we will discuss the classification of iron losses. Iron losses are further classified in two categories. One is hysteresis loss and other one is eddy current losses. Hysteresis losses basically occur in transformer core because of the continuous reversal of magnetization of transformer core under the influence of alternating flux. These hysteresis losses are given by the formula WH is equal to eta Vmax raised to power 1.6 FV watt, where eta is hysteresis coefficient, Vmax is the maximum flux density in the transformer core, F is the supply frequency, and V is the volume of transformer core in cubic meter. And the eddy current losses occur in the transformer core because of production of eddy currents. As we know, eddy currents are the circulating current which developed in the body of transformer core due to the working flux of the machine. And these currents can be minimized by the help of laminated iron core. The eddy current losses, they are given by the relation WE is equal to KE Vmax square F square E square into V, where again K is the eddy current coefficient, Vmax is the maximum flux density in the transformer core, F is the supply frequency, T is the thickness of laminations, and V is again volume of the core. And at any stage, if we combine both the losses, hysteresis loss and eddy current losses, we will get iron losses. From these two expressions, it is obvious that the transformer iron losses mainly depend upon the flux density, or we can say flux of the machine, as we are assuming that supply frequency is of AC is constant and it is not going to change. So transformer iron losses mainly depend upon the working flux of the machine. And as we know, the working flux of transformer practically remains constant. So this is the reason why the iron losses of a transformer is also constant, no matter what are the load conditions. Transformer, whether it operates on no load or at full load, the working flux of transformer practically remains unchanged, and as long as the flux is unchanged, we can say the iron losses of machine is also constant. Now, the important point, how we can measure these iron losses. The iron losses of a transformer are measured by performing open circuit test. Here is the experimental setup of open circuit test. Here we can see that we are having a transformer. On primary side, we have connected a source of variable AC supply in the form of variac or auto transformer, and along with auto transformer, a voltmeter, a wattmeter, and ammeter is connected on the primary side, with secondary winding of the transformer is kept open. In some cases, we connect an additional voltmeter on secondary side like this, and the purpose of this voltmeter is just to measure the voltage developed across the secondary winding, so that we can easily calculate the transformation ratio using this formula V2 upon V. The important point while performing open circuit test is that this open circuit test is conducted at rated voltage of the primary side. So the procedure for performing this test is we increase the voltage from the auto transformer by keeping an eye on the voltmeter reading. We keep on increasing the voltage till the voltmeter reading is equal to the rated voltage of the primary side of this transformer. In this situation, the wattmeter reading, we can assume that the wattmeter reading directly provides us the value of iron losses. While performing open circuit test, certain assumptions are made here, and one important assumption is that we are neglecting the copper losses of the machine. The reason behind neglecting copper losses of transformer is in open circuit condition, the current flowing in secondary winding, current on this particular side as the terminals are open, so this current is zero. And on primary side, only the no load current is flowing. As we all know, the value of this no load current is very, very small. It is hardly 1 to 2% of rated current of primary. So in this situation, because of very low current in transformer windings, we can assume that the entire copper losses can be neglected. And it is assumed that whatever power taken from the source is dissipated in the form of iron losses. And the value of this iron losses we can measure directly from the reading of the wattmeter. So this is how we conduct open circuit test. One more important point is this open circuit test is always conducted on low voltage side. Generally, we prefer to conduct this test on low voltage side and high voltage side is kept open. There are mainly two reasons for this preference. First reason is on low voltage side, as we know, this test is conducted on rated voltage. So on low voltage side, the value of rated voltage is small. So if we conduct open circuit test on LV side, it means we have to operate at a lower voltage. So if we have to operate at lower voltage means we need equipments of lower voltage ratings. So because of conducting this test on low voltage side, it is also advisable, it is also beneficial from the operator's safety point of view. So these are the main reasons which force us to conduct this test on low voltage side. First is we need instruments of lower voltage ratings, and second thing, the operator safety is also ensured if operator is operating at a lower voltage. We can clearly compare the difference of transformer voltage ratings in a ordinary distribution transformer. As we know, one side we are getting 11 kV and other side we are getting only 440 volt. So, but obvious that everybody will prefer to work on 440 volt. This is the main reason why this open circuit test is always conducted on low voltage side with high voltage side is kept. Now, from the readings of open circuit test, we can also calculate the parameters of equivalent circuit of a transformer. The no load parameter, that is core loss resistor, which is represented as R0, and magnetizing reactance X0. Both these no load parameters of equivalent circuit of a transformer can be calculated from the data of open circuit test. And these two parameters are available on the side at which this open circuit test is conducted. The calculations for open circuit test is as follows. Let us assume that P is the wattmeter reading, V is the voltmeter reading, and I0 is the ammeter reading of open circuit test. So here P directly represents the value of iron losses. So using these three readings, first we can calculate no load power factor of primary side. Cos phi naught is equal to P upon V I naught. Using these three readings, we can calculate no load power factor. Then we can calculate working component of no load current, that is IW, and I mu, it is the magnetizing component of no load current. The working component supplies no load power losses, and the magnetizing component is responsible for production of working flux of the machine. Once these two components are calculated, then the corresponding value of core loss resistor can be calculated by dividing the supply voltage with working component of no load current. And similarly, the magnetizing reactance X naught can be calculated by dividing the supply voltage with magnetizing reactance. So in this manner, from the open circuit test data, not only we can calculate iron losses, we can also calculate the no load parameters of equivalent circuit. So this is how we perform the open circuit test. This is the reference used for making this video. I hope from this video, the purpose and the procedure of conducting open circuit test is clear to you. Thank you.